Hello everyone, welcome to today's class. This is Teacher Simon taking you through AS Pure Mathematics 1, and this is paper 9709/15 for May June 2025, and this is part 2 for questions from 7 to 10. Question 7. In the parallelogram ABCD, the coordinates of A are 3, 7, the coordinates of B are 6p, and the coordinates of D are 1p. It is given that the gradient of AB is negative 2 over 3. Find the value of p. If the gradient here is a negative, then it has to be like this. You get it? The line has to be like that. Now, I'm going to do a small sketch here, okay? The parallelogram, so suppose we have that, and then this one may be like that. Then after that, of course, I'm going to duplicate this one here. It is parallel to the other one there. And then this one here, I also duplicate it. Then I bring it here. Then it will give me a parallelogram. Now, I'm going to have, since the gradient here is a negative, then we can have maybe A here. A, which is 3, 7. Then B has to be on the right of A, okay? Because the x coordinate you can see, it is bigger than this one here. It's bigger than the 3. So 6. Then we have P, AB. Then this one has to be the C. And then D here, 1P. So if this is 1P, then that means this one has to be parallel. Yep, it is parallel to x-axis because they have the same. You see that? Then our C here, we don't know it. So let's say this is AB. Now here they said that the gradient of AB is negative 2 over 3. Gradient of AB is equal to negative 2 out of 3. Now, how do we get the gradient? Changing y over changing x. So we shall have p minus 7. Then we divide by 6 minus 3. If you started from here to subtract, you say p minus 7. Then come back to this and you say 6, then minus 3. If you interchange them, and then you say p minus 7, then divide by 3 minus 6, you get it wrong. So be careful there. And this one is going to be equal to negative 2 out of 3. So our p here, minus 7 here, is going to be equal to, this is a 3, not so? Now when we cross multiply, we shall have negative 2 over 3, then times the 3 here. Therefore, p is going to be this one going, will give us a negative 2. Then we shall add the 7 there. Then our p becomes a 5, not so? 7 minus 2. As simple as that. Then, next, find the coordinates of C. For the coordinates of C, this one here is parallel to this. And also this one is parallel to this one here. And we know that parallel lines have the same what? Gradient. So I will say parallel lines have the same gradient. So this therefore implies that the gradient of BC is equal to the gradient of AD. BC is equal to the gradient of AD. Now, the gradient of BC, I can say B minus the P, so minus the 5, then over A minus the 6, right? So we have B minus 5 over A minus 6. Then gradient of AD, when we look at A and D, we shall have 5, D here is 5, then minus 7, and then 1 minus 3. So 5 minus 7, 5 minus 7, and then 1 minus what? 3. Suppose we cross multiply, this one will give us b minus 5 will be equal to, this one is a negative 2 over a negative 2, that's a positive 1. So we have 1 into a minus 6. In other words, b is going to be equal to a minus 6, then plus 5. So b becomes a minus 1. I can keep this one there. And then I'll also go to the gradient of DC, which is equal to the gradient of AB. Okay, gradient of DC is equal to gradient of AB. And here we shall have B minus the 5 over A minus 1. Okay, B minus 5 out of A minus 1, which is equal to the gradient of AB was given as negative 2 over 3. When we cross multiply, we shall have B minus 5, which is equal to negative 2 over 3 of A, and then plus 2 over 3. You get it? Now, this simply implies that B shall be equal to negative 2 out of 3 of A. When it comes to this side, it's a plus. So we have plus 2 over 3, then plus 5. And our B here is going to be equal to negative 2A over 3. This is 15 plus 2. Isn't that a 17? I think. So plus 17 over 3. That is what we are having. So solving the two equations, we shall just equate them. We have a minus 1, then is equal to negative 2a over 3, then plus 17 over 3. So bring this one this side, or I can first multiply all through by 3 to eliminate the denominator. That means here we shall have 3a minus 3, which is equal to negative 2a plus 17. Bring this one here, it becomes a 5a. Then take this one this side, it becomes a 20. That means a becomes what? A 4. And then from here, our b is going to be 4 minus 1, which is a 3, not so? So meaning the coordinates of C are going to be 4, 3. As simple as that. Part C, find the area of the triangle formed by the perpendicular bisector of AB and the x-axis and y-axis. Okay, now our sketch here, remember I had, let me put it here, maybe like that, and then we also have this other one here, like that. Then this one, I put it here, and then this one here, I also put it there. So that is my parallelogram. And on the axis, we shall have something like this. Just a small sketch here. So we have our A here, which is 3, 5. I mean 3, 7. Our B here, if we can check again, our B is 6P. 6, then P. Is the P we got as a 5. So you can see this is a 7, this is a 5, so it is below the 7. You see that? Then next, we have our C, which is 4, 3. The 3 is below 5. And this 4 is in between the 3 and the 6. You see that? Then our D was given as a 1, smaller than 3, this 6, and then the 4. And its y coordinate was a 5. It was a P, so it is parallel, you see, to this x-axis. So this is y, and this is what? X. Now, they said we find the area of the triangle formed by the perpendicular bisector of AB. Okay, x-axis and y-axis. So perpendicular bisector of AB then has to be like that. Okay, the perpendicular bisector of AB will be maybe like that. It has to be perpendicular to what? To AB, and has to pass through the midpoint of AB. You see? Something like that. Now we need midpoint. So I need to write something here. A perpendicular bisector. Perpendicular bisector always passes through the midpoint of a line segment. Okay, so midpoint of AB, of that line AB, is going to be the average of the x coordinates, 3 plus 6 divided by 2, and then the average of the y, 7 plus 5 divided by 2. Not so? And then here we shall get 9 over 2. And then this one will give us 12 divided by 2, that's a 6. Then we also know that for perpendicular lines, okay, then for perpendicular lines, m1 times m2 is always equal to -1. So gradient of this bisector is going to be -1 over gradient of AB was given as -2 over 3, which is now 3 over what? Over 2. Okay, remember I need to find the equation of this line. Okay, they said find the area of the triangle formed by the perpendicular bisector AB of AB, the x-axis and the y-axis. So that means we are going to continue this one down here. Okay, and when we continue it down here, this one also will continue down, so it will meet this y-axis down this way. Okay, now the triangle we are forming, they are saying y-axis, the line, and then the x-axis is this one. You see that triangle? So we need this x-intercept here. We need to find this x-intercept where this line cuts x-axis and also where it cuts the y-axis. You see that? Then this will be our base maybe, and this will be our height. So as simple as that. So using y minus y1, which is equal to m into x minus x1, the coordinates through which this line passes, we have 9 over 2 and then 6. So this will be y minus, our y1 is a 6, then m here is 3 over 2, and then x then minus, what will this one be? The x1 is 9 over 2. Then Remember, we are supposed to get where it intersects x-axis. So we can say on x-axis, then y is equal to what? 0. So when I substitute it here, it will be -6, which is equal to 3 over 2 into x here minus 9 over 2. Then we shall get -6. When we cross multiply times 2, then we divide by 3. This one will give us x minus 9 over 2. So x then will be equal to, this one goes here 2 times. So 2 times 2, that's a 4. We shall get this one as a -4. Then bring this one this other side. It becomes a positive 9 over 2. What does this one give us? When you multiply here, you get -8 plus 9. That would be a 1. So we have 1 over 2. Okay. Then after that, we can now go on and find, we can say also that on y-axis, x is equal to what? To 0. So we substitute here. So y minus 6 then shall be equal to 3 over 2. Then inside here we shall have 9 over what? Over 2. So this means that our y is going to be equal to -27 out of 4, then plus the 6. Okay? And what do we get here? That means we shall get this 4 times the 6. You get 24. Now -27 plus 24, you get -3 over what? 4. So this implies this one here is going to be -3 over 4. And here we are having a half. So area of the triangle, formed, remember, is equal to a half times the base, then times the perpendicular height. Now, the base is going to be a half, like I told you here. Then the height is this one. And length cannot be a negative, so we are not going to say -3 over 4. We are going to take it as 3 over 4. So times 3 over 4. Now this is a 3 over 4 times 4, that's a 16, not so. So it will be 3 over 16, as simple as that. Question 8, the equation of the curve is given by this. The curve has a stationary point at 1, 9. Find the values of A and B. So first of all, since this equation lies on this curve, then its coordinates must satisfy the equation of that curve. Okay, so if we have 1, 9, that simply implies that our y is a 9, then our x is a 1. So I just substitute in this equation here. Okay, then I'll get one equation in B and what? And A. So we have here A, then plus B, which is equal to, this is 5 plus 1, that's a 6. So when it crosses, we have 9 minus 6, that will be a 3. So this will be a 3. This is my equation 1. Then this is a stationary point. Then we need to get dy dx. Because for stationary points, dy dx is equal to what? To 0. All right. So let us differentiate this. Dy dx shall be equal to 3x squared, then plus 2ax, then plus b. And like I've said, for stationary points, dy dx is equal to what? To 0. Now you are having your stationary point 1, 9. So when I put 1 wherever there is x, then I will equate this one to 0. So I will have 2a plus b, which is equal to -3. This is my second equation. So solving 1 and 2 simultaneously, we shall have 2a plus b is equal to -3, and then a plus b, which is equal to 3. I'll just subtract here such that b disappears, okay? And then we get a, which is equal to -6 here. As simple as that. Then what will be b? So b is going to be equal to 3. I can substitute in the first one here, minus a. So that will be 3 minus -6, and that one will be a plus. So then b becomes a 9, as simple as that. Part B, find the coordinates of the other stationary point. So we shall get our dy dx here. We got it as this, okay? 3x squared, our dy dx is going to be equal to 3x squared, then plus 2ax, 3x squared plus 2. Our a, we have gotten it as -6, not so, of x, then plus b. So plus b, it is a 9. Okay, so we shall get this 3x squared minus 12x, then plus 9. We shall equate it to 0. If we divide all through by 3, if I put it out, then this one will be minus 4x, then plus 3, which is equal to 0. This 3, when I multiply the two numbers to give me a 3, that will be 1 and 3. But when I add them, they should give me a negative 4. That means these two numbers must all be negative. That means we shall have 3, then x minus 1, and then x minus 3, which is equal to 0. Therefore, x will be equal to 1, or x will be equal to 3. Now, for these two x coordinates we have gotten, we need to pick one. When you check this one here, the x coordinate we can see is a 1. That means we are going to consider 3, okay? So we shall say for x, which is equal to 3, then y is going to be, this is x cubed, so that will be 3 cubed, and then we have ax squared, and our a is a -6, so -6, then 3 squared, then it is a plus bx, so plus our b is a 9, then x here, and then plus 5. This is 27 minus, this is 9 times 6, I think that's a 54, and then plus, this will be 27, then plus 5. 27 plus 27 gives us a 54, minus 54, so this whole thing goes, and then we remain with a 5. So this simply implies that other stationary, the coordinates of the other stationary point will be 3 and then a 5. As simple as that. Then part C, a point P is moving along part of the curve in such a way that the y coordinate of P is increasing at a constant rate of 6 units per second. Find the rate at which the x coordinate of P is increasing when x is equal to 5. This one stems from connected rates of change in differentiation. Now we have what we are given is dy dt, which is 6. Okay, they said it is increasing. Suppose they said that it is decreasing, then that means we would put a negative here. Okay, mark that. All right, now we have y, which is equal to x cubed minus 6x squared plus 9x, then plus 5. So, and our dy dx is going to be 3x squared minus 12x, then plus 9. Okay, now for x, which is equal to 5, what is the value of dy dx? So we are going to have 3, then times 5 here squared, minus 12 times 5 plus 9. This one is 75. then minus 60, which is a 15. 15 plus 9, isn't that a 24? Yes, I think that is a 24. Now, we need dx dt. So I'll put here dx, then I'll put here dt. But x and y are connected, so I will say dy, then here dy. Now, dx dy is equal to 1 over dy dx. So that means we shall have 1, then out of the 24 we got here, then times our dy dt, which is a 6. And 6 goes into 24. How many times? 4 times, right? So that means our final answer becomes what? A quarter. As simple as that. Question 9. Functions f and g are defined as follows. This is what it is here. And then they are saying part A, describe fully the transformations that have been combined to transform the graph of y is equal to f of x to the graph of y, which is equal to the g of x. Now, we have our y1, which is equal to the cosine of x. Then, the second one, we see that there is something that has been done on the x. Okay? So, I will say, I first consider these 3 being multiplied. So 3, then times the cosine of x here. Okay? Now, since this function has been multiplied by 3, then this one will be a stretch. A stretch by factor 3, then parallel to y axis. Okay? That is 1. Then we continue. Y3 is going to be y3 is now going to be, we are putting this one here, so 3. If there is an addition or a subtraction on the x or on the y, that is a translation. If there is a multiplication or division on x or on y, then that is a stretch. And then if there is change of sign for x or y, then that is reflection. All right, so here we shall have x minus pi and then plus 2. When this one pops out of this, now we can see first of all that we are subtracting something from x, so that is a translation. It is a translation by vector. When this one pops out, it comes out as a positive, so it will be pi. Then this one here is the movement in the y, which is a 2. So this is what we are having here, translation by this vector, and then stretch by factor 3, which is parallel to what? To y-axis. So those are the transformations we have there. Alternatively, because the order in which the transformations are done is very important, it matters. So if we have g of x here, I can put the 3 like this, and then inside here I have cosine of x minus pi, then plus, this will be 2 over 3. You see that? When you multiply all through by 3, then you get this one here. So I just factorized out a 3. Now that means we first do a translation, which is inside here. Okay, so we shall have translation by vector. Pop this one out. It is going to be pi. Then this one is 2 over 3. And then the stretch comes after, because it multiplies everything in here. Then we say stretch by factor 3, then parallel to y axis. So you can have this one first, and then next you have this one. So that is that. Part B, on the y-axis, sketch the graphs of y is equal to f of x, and then y is equal to the g of x. Now, what we can do is to find coordinates, okay? I will draw here a simple table. So I have x, and is 0, then pi, and then 2 pi. Then we are having two graphs. So we have the one of f of x, which is cos x. So g of x is equal to 3 cos of x minus pi, then plus 2. And then f of x is equal to the cosine of x. So cos of 0 is a 1. Cos of pi is a negative 1. Cos of 2 pi is a 1. Okay. They want us to go up to, is it 2 pi? Yes. Now for cosine, we shall go up to pi. We shall not need 2 pi. So I won't need this one here for cosine. Then for the second one, it is from pi to 2 pi. Okay, pi to 2 pi. So put pi here. That means we shall have cos of 0, which is a 1. Then 3 plus 2, that one will give us a 5. Then 2 pi minus pi, that one will give us a pi. So cos of pi is a negative 1. Now negative 3 here plus 2, you get a negative 1. So we shall have a negative 1 here. So when I draw, I will have, let's say this one here is a 5. And of course, the maximum for this one has to be a 1. Yes. So if I have 1 here, 2, 3, 4, and 5, the maximum for this one is going to be a 5, because we know that cosine, its maximum value is a 1 and its minimum value is a what? Is a negative 1. So if I put 1 here, then this will be a 5. That will be its maximum. And then its minimum, that is when this one is negative 1. So it will be that negative 1. So we have a negative 1 here. And when I'm drawing, I shouldn't go beyond this point here. Okay. And also, I shouldn't go beyond this point here. It's as simple as that. But I don't need these, so I need to just make them dotted. I'm not supposed to exceed that line, and also here the same. Now let's begin with this one of f of x. So we need 0, 1, which is here, and then pi, and then negative 1. Cos of 90 is 0, so that means in the middle here, that is where it is going to pass. Okay. And also this one here cannot exceed 1. So that means when I'm drawing, I have to carve this one off here. Then I come like this, then like this one here, and I would stop it there because it doesn't go beyond this point based on the domain given. Okay. And then the other one is going to be, for this one, 5 and then negative 1. So we have 5 here, then negative 1 here. That means if I can even use another, so this is the maximum and this is its minimum. So you draw here, then you bring it down like this, and then you curve it just like that. So if it is proceeding, then it will go like that. You get it? because this is the minimum, but you don't go beyond that point there. So I can label them that this is my y, which is equal to the g of x, and this is my y, which is equal to the f of what? F of x. So that is that. Part C, find the g inverse of f of pi over 3. That means this f of pi over 3 has been composed into the g inverse. Okay, now we need to find the g inverse. If the g inverse of x is equal to y, that means x is equal to the g of y. That is the same as saying interchanging x and y. So 3 cos of, we have x minus pi, so that will be y minus pi. Then plus what? 2. Now we make x the subject. So bring this one here. We make y the subject. Bring this one here. We shall have x, then minus 2. Then we can divide by 3 to get cos of y minus what? Pi. Then here we shall take the arc cos of x minus 2 over 3, then which will be equal to y minus pi. So taking this one here, that means y shall be equal to pi, then plus the arc cos of x minus 2 out of 3. Also, so this therefore implies that the g inverse of x, it is going to be pi, then plus the arc cos of x minus 2 over 3. Then we need to get f of pi over 3. So f of x, we know it is equal to cosine of x. So meaning f of pi over 3, that will be cos of pi over 3, which gives us what? A half. Now g inverse f of pi over 3 will be equal to the g inverse of the result we get from here, over half. Then we substitute in this one here, okay? Pi, then plus the arc cos of, these are half minus 2 over 3. Not so? So a half minus 2, then that negative 1.5. Then divide by 3, that will be negative a half. Negative a half. And cos is negative in the second quadrant, not so, and third quadrant. So we are looking at this and this. So I'm going to take this one here, will actually give us 120. So it will be pi, then plus 2 pi over 3. So this times that, what do you get? 3, then plus 2, that's a 5. So we get 5 pi out of 3. And this will be our answer. Then part D, they are saying, explain why the composite function fg cannot be formed. Now here, let me do for you something here. We are having x. Then g first acts on that x. What comes out is the g of x. Are we there? Then f now acts on the result here. Then what comes out is the fg of x. In other words, the whole root here is going to be the fg. Now, remember what we put in the function must be the domain. So, since what we get out of here is now the range of g, so here we have domain of g. What comes out is the range of g. Are we there? But it has to fit into the domain of f. What is here is the domain of f. Then what comes out here is going to be the range of what? the range of f. You see? So explain why the composite function fg cannot be formed. Now, let's look at the range of g. Range of g. So the range of g, right from here, I told you, its maximum is going to be when you put here a 1, because cos does not go beyond what? A 1. So this is 5 plus, 3 plus 2, that's a 5. And then its minimum, that is when you put a negative 1 here, because that is the smallest for the cosine. And then negative 3 plus 2, you get a negative 1. So meaning the range of g is going to be negative 1, okay, less than or equal to x. No. I'm going to put g of x because we use what? When it comes to the range, we write it in terms of the function. Then when it comes to the domain, we write it in terms of what? Of the variable. That is, let's say for this case, the x. Now let's look at the domain of f. When we go back and we check here, we are having the domain of f is this one here, 0 to pi. So it is 0 to pi. Now pi is 3.14, maybe 142, okay? Now, here we are having negatives. So it's like you are having something like this. If you look at a number line, you have a negative 1, then a 0, maybe 1, then 2, then 3, then 4, and then 5. Okay? We are continuing like that. So g is here. Okay? This is our g of x. It is taking all of these values here. But then f of x, for it is from 0 here to 3 dot, the domain, the x values that are supposed to go in f, 3.142, which is maybe, let's around there. You see that? This is the 0 less than x less than what? Pi. Now, you can simply see that this range of g, okay, does not fit into this domain. So since the range of g does not fit into this domain of f, then we cannot get the what? We cannot compose g into f, okay? So I will say here that the range of g, okay, does not fit into the domain of f. This will be our answer that is needed. So whatever I've done here is not needed, but I just explained each and everything such that you understand. Okay, we just need this statement. It's just 1 mark. Question 10 is coming from circles. The equation of the circle is this one here, but find an equation of the tangent to the circle at the point 28, giving your answer in this format here. All right. Now, we have this one here. We need to complete squares such that we find the center of that circle. Okay, so we have x squared then plus 4x. Let me rearrange such that x and the x parts are together and also the y parts. So y squared then minus 8y. I can take the 12 this side. Complete squares, divide this by 2. You get a positive 2. You put it together with the x, then you pop it out here as a square. And then here, 8 divided by 2, that's a negative 4. Then you pop it out here as a square. Then this one will be equal to the 12. So meaning we shall have x plus 2 squared, then plus y minus 4 squared. This will be equal to 12. Then plus 4 squared is 16. Then 2 squared is a 4. So this is 20, then plus 12, isn't that 32? So that means we have this one here, which is equal to 32. So when we compare, okay, so comparing with the general equation of the circle, which is x minus a bracket squared, then plus y minus b bracket squared, which is equal to r squared, where the center is AB. This therefore implies that the center of our circle here is -2, because you equate this one to this and this to that. So we shall have -2 and then 4. Okay, now I'm going to have a circle here. The center here is -2, 4, and then they are saying the point 2. 2 has to be on the right of -2, and then 8 has to be above 4. That means maybe it is around there. So if I put it here, and that is the point 28, then I'm going to have a tangent. This tangent is meeting that circle at that point. So on the look of things, this one has to be having a negative what? Gradient. So this is the tangent. And then we know that in circle properties, the tangent is always perpendicular to the radius. So we need to find m1. m1 is going to be the gradient of the radius. So we have change in y, 8 minus 4, then 2 minus minus 2, 2 minus minus 2. And of course this one will become a plus. So we shall have 4 over 4, which is actually 1. And then for perpendicular lines, we know that m1, m2 is equal to -1. So gradient of the tangent here is going to be equal to -1, then divide by the gradient we have gotten here, which is a 1. So meaning altogether that is -1. Now, in order to find the equation of a straight line, we need first to get its gradient. Then number 2, we need to use a point through which it passes. So using y minus y1 as the general equation of the straight line, which is equal to m into x minus x1, we are using 2, 8 here. Now we shall have y minus, what is y1? So y1 is 8, and then our m here is -1, then x minus the 2. So meaning here we shall get -x, then plus 2. When this one crosses, it's a plus, so plus 8. And then finally, the equation of the tangent here is going to be y, which is equal to -x, then plus 10. You can actually see that the gradient of the tangent is a negative and the line is slanting like that. So that is that. Part B, given that the line x plus 3y is equal to k does not intersect the circle, show that we have this inequality here. Okay, now what I can do, of course we are solving these two simultaneously. We have x plus 3y, which is equal to k, and then the equation of the circle is here, x squared plus y squared plus 4x minus 8y minus 12. X squared plus y squared plus 4x minus 8y minus 12, which is equal to what? 0. We need to make one of the unknowns here, or one of the variables, the subject of the formula, and then we substitute in this other one. The easier one to use is x. So make x the subject of the formula will be k minus 3y. So this implies that here we shall have k minus 3y squared, then plus y squared, then plus 4, and then we put k minus 3y. Remember, wherever there is x, we are replacing it with k minus 3y, then minus 8y minus 12. Now this one will give us a quadratic in y, okay? So let us simplify this one, or we expand the brackets. This will be k squared minus 2 times k times negative 3y, that will be negative 6ky. Then square this one here, it will be 9y, then y squared, then plus 4k minus 12y, then minus 8y minus 12, which is equal to 0. So y squared, it's a quadratic in y, right? And by the way, there is a square here when I square here, pardon me. Okay, now this is 9y squared plus y squared, isn't that 10? So that is 10y squared. And then from there, plus, let's get the coefficients of y. We are having, this is 4k. There is also negative 6k. No. Pardon me here. This one here, these two are going to give us negative 20. Not so? And then there is this negative 6k. So I'll say that we have negative 20 minus 6k. All of them give us the coefficient of y. And then the constant part, that is where we are not seeing any y. So there is k squared. Then there is also 4k. And there is also negative 12. So 4k and then negative 12. So the constant part here is another quadratic also. Now, they said that they do not intersect. Remember, the quadratic equation we get here is the one we are supposed to use to solve the equation. Okay? I mean, is the one we are supposed to solve in order to get the points of intersection. And when we are solving, let's say for y here, y is going to be equal to minus b plus or minus to the root of b squared minus 4ac out of what? 2a. You see that? So this is the b, the whole of this is the a, and then the c is the whole of this. You see that? Now, when we substitute in here, this discriminant here determines the nature of the roots you are getting from here. If this one is equal to 0, that means this whole thing is going to disappear and you have only one root. We call it the repeated root. Or that means the line and the curve are meeting at only one point. And the x-coordinate of that point is going to be negative b out of 2a. Are we there? So in that case, the line becomes a tangent, because a tangent is that line that meets the curve at only one point. Now, suppose this b squared minus 4ac is greater than 0. That means you will be in position to get the square root of this, and you will consider the plus and the minus. So that means you're going to get two values here. So that's why we say there are two distinct points. That is when b squared minus 4ac is greater than 0. But if this one is less than 0, okay? If this one is less than 0, that means you're not going to have the square root of the negative. You are going to get complex roots, but not real roots. And here we are talking about real roots. You get it? So we therefore say, for no intersection, b squared minus 4ac has to be less than what? 0. What is our b? Negative 20 minus 6k. We square it. Then minus 4 times our a is a 10. Then our c is k squared plus 4k minus 12, which is equal to what? No, not equal to 0. It is less than 0. Now, square the negative 20, you get positive 400. 2 times negative 20, that is negative 40. then times negative 6k, positive 240 of k, then square this one here. That one will give us 36k squared. This is 40 times the k. That will be now negative 40k squared. Negative 40 times 4k, that will be a negative 160k. Not so? And then 40 times 12, that is 480. A negative times a negative, that's a positive. So positive 480. You have to be careful here with the signs. Then here we have 36 minus 40. That is a negative 4k squared. Then 240 minus 160. That one will give us 80. Okay. That one will give us positive 80 of k. And then 400 here plus 480, isn't that 880? So plus 880 less than 0. I can divide all through by negative 4 to simplify this, and to also make the coefficient of what? K squared positive. So that means we shall have k squared. 4 goes in here 20 times, but it will be negative 20. And then 4 goes here 22 times, not so? Then there is a 0. So, but since I'm dividing a positive by negative, then I'll have a negative. So 220. And then when you divide an inequality by a negative value, or you multiply all through by a negative value, the inequality sign changes. So this one will change to greater than 0. The inequality we have gotten here is exactly what they have told us to find here. You see that? So this is our answer here. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.